I have problem 4 of the Expert TA homework. It says a participant in a winter sports contest pulls a 45 kg block of an ice in the positive horizontal direction, with a cable over his shoulders over a frozen lake as shown in the figure. Assume the coefficients of static and kinetic friction are mu s equals 0.1 and mu k equals 0.03. In this figure, the person is going to be pulling the block of ice using a rope inclined above the horizontal of 25 degrees, which would be right here. And this is going to cause a component of their force to be upwards, which is shown in this diagram that I drew right here with the force. And that's going to reduce the amount of normal force required to balance the gravity, which is pointing down. And because the normal force will be smaller, the friction is going to be smaller as well. So it asks in part A to find what is the force that they would have to apply along the rope to barely start the ice cube accelerating. So right here, we do have the equation of how to get the answer, but I'm going to break it down to get the equation for you. And this would start with our net downward vertical force on block, which is our mass times g minus our F times sine theta, or in this case, it would be the numbers 45, which is our mass, times 9.8 gravity, minus F times sine 25 degrees, which was in the picture. Next, we have to use our resistive force, which equals mu times mass times g minus F times sine theta, which equals our 0.1 that was shown in the question, times 45, which is our mass, times 9.8 gravity, minus Fx sine 25 degrees. Hence, this is to get the block moving, we must have our F times cosine theta equals our mu times mass times gravity minus our F times sine theta. And because we do not have F, we have to rearrange the equation to make it equal to get our answer. So once we rearrange, it's F equals mu times mass times gravity divided by our cosine theta plus our mu times sine theta. And that is the equation up here. This is just written out, and this is where our answer would be. So for our part B, it asks, what is the acceleration in meters per second squared once it starts moving if the force is maintained? So now that we have our force, we can do our part B to get our equation. So this would be the equation to find the acceleration, but I'm going to break it down for you guys to see how to get the actual equation up here. So our net force, horizontal force on the block, once it is moving, equals our force times cosine theta minus our mu k, which is our 0.03, that was also in the question, times mass times gravity minus F times sine theta, where UK is kinetic coefficient of friction. This force equals mass times A, where A is acceleration. So that means mass times A equals F times cosine theta minus our mu k times mass times our gravity minus Fx sine theta. So once we rearrange that, we will get the equation to find acceleration, which equals F times cosine theta plus our mu k, 0.03, times our sine divided by our mass minus our mu k, also 0.03, times gravity, which will be the equation right here at the top, which will give you the acceleration of 0.656 meters per second squared.